much, Dr. Chandra, and I'm grateful to Dr. Shyam Sundar, and I'm grateful to the organizers for having considered to speak something about structural integrity. Now, I find that there are multidisciplinary gathering here. So I would begin with the definition of integrity itself, because each one of us, have a different way we look at integrity. Sorry for being in this pose. I'm used to this. Even I would walk like this, but not able to stand there till my slide comes on. Integrity in terms of civil engineering has a very different meaning, in fact. But finally, the end result is same, and all of us look at the integrity of the whole issue. I mean, whether it performs as we had expected, whether it performs whatever, I mean, whether it's structure or infrastructure or building or whatever, or a process, it performs to our standards, what is qualified. So that, I think, we set some standards, and over a period of time, that is today, tomorrow, and the day after, whether it sustains the same level of performance, and that's the issue. And why there is to be a degradation of performance, I think we should question ourselves. Engineers, they give you full of paradoxes. Life itself is a paradox, but engineers create more paradoxes. He said something about the wheel, and we also say in mechanical, don't reinvent the wheel. So why should I look for 24? I mean, so it's something like that. So there are certain things we always review and relook at what we have done. So similarly, that what happens is we do not have in engineering, we always follow most of the time deterministic approaches. That means we think we know, but there are many uncertainties that are consumed or embedded into what we do. So as I always say that in engineering, the first thing which we do is we begin with assumptions, and we forget what is the assumption at the end of the day when the product is ready. And while doing the design, we always introduce approximations as well. So there is a huge difference between what we assume in the beginning and what we end up with approximations as a solution and a design. So I ask myself, why do I have to do this structural integrity assessment? Assessment is a very strong word, actually. I mean, also it is not very quantifiable many times. Assessment can be very empirical, highly challengeable. I mean, what in my assessment, if I say he's a good person, for somebody, he may not be a very good person. So it's very subjective, it becomes very subjective. So our challenge as engineers to look at the investment which we have made, which is supposed to be durable, sustainable, is to look at whether it performs generally to the expectations as per the standards. We also, as we do many things during the life of the structure, it undergoes several changes. What we have conceived in the beginning, probably it doesn't, as the technologies change, as the functions change, it also changes, it brings in changes in the terms of the deterioration of the materials, and as a result, in civil engineering, what happens, a structure or a building or an infrastructure it comprises many elements, structural elements, and each element has to be checked for its adequacy, checked for its performance, and on the whole, we have to look for its integrity. So that's another challenge. That's why we need number of stages of working, which leads to structural integrity assessment. So as was my predecessor were talking about change of loading, I will actually discuss our personal experiences in terms of one decision made by someone in the ministry has caused several such challenges for all engineers to look at the performance of some of the infrastructure. I would do so. I have not included in my slides for want of many things. One is some of them are sensitive, and some of things in terms of the time. I thought I will not introduce. Now, this just to give an idea, since this is a multidisciplinary audience, I thought I should also define when I say a building or when I say an infrastructure, how do we define that? Each one, as a designer, we are supposed to give some life. For example, this seminar hall or this whole building or this complex, we say that this is going to, I design it for 50 years or for 100 years as life. So when I make that as a starting point, base point, that's an assumption I make, and with that assumption goes my investment. So if I want to increase its life, I have to invest more. It's not necessarily a linear proportion, but some proportion more. So this is what one of the standards. This is I just try to define, that it is not that straightforward that you look at a building and you say that this is not workable or it doesn't perform. We have to always keep that in mind. When a particular building is existing, it should be belonging to one of these categories. And looking at those categories, we should know whether it has achieved its life or it still has life. And with reference to that, what is the degradation and how to make up that life cycle? What is the remaining life of that particular structure? So that is how the algorithmic steps are in terms of assessment of its integrity. So this is one of the way to quantify. Now there are few steps, as I said. See, it's a little complex when I talk about an infrastructure. It could be a metro, it could be a complex, it could be a mall, it could be an institutional building, etc., hospitals, healthcare systems, and etc. So there are a number of things. So what we do is to make things very simpler and easier. We go by certain steps which give you a way to invest more time and more money in making an assessment of its integrity. So we said first we make a visual inspection. That means we evaluate the condition of the structural elements. So we go by elements like beams, columns, etc., slabs, or the overall wall and the system itself, the foundation, etc. So we do some visual inspection. Through that we get some idea. It is just like a patient going to a doctor. The initial symptoms gives you some indication whether the temperature is right, whether it's body ache, whatever distress, etc. in a body, in a system. So he gets an idea. Then he says, let's go for a more detailed test. So this is similar to that. If you can see the another, is that we go for what is known as non-destructive testing. That is, you don't harm the structure, but we can find there are some cracks, but we don't harm the structure further. And there are a number of technologies that are available. We make use of those technologies. Again, this becomes highly interdisciplinary. It is not necessarily it is a civil engineering. The non-destructive testing thing came from mechanical and electronics. So that's how it got into the civil engineering. And I have added a word called evaluation. So it is not a simple thing of just doing tests. It's beyond testing, is to interpret the observations you make. And there lies the skill actually, how to interpret and what kind of observations you make. And then what is known in civil engineering is number of loads. That means a structure goes through their different loading patterns. So whether it is a road bridge, highway, train, or railways, whatever. So we have a number of load tests we do. We conduct a mock test, then we try to put a real field test actually, and look at its performance and whether there are further distresses. Could be the cause of distress itself. We find out and we find a solution, something called retrofitting, etc. But this is not, in terms of load testing, it cannot be done individually because you need another tool. That is the next which I have listed is structural health monitoring and management. Now, many people, many times, we forget the last part of it, management. I'll tell you, there are certain personal experiences of ours where management becomes important. There are sensor technologies we use, there are a number of advanced technologies. Then comes the computational modeling and analysis, which is very important. It is, it's a forecasting and a predictive model. It tells you what if situations, different what if situations. That means if I do like this, if a structure has to undergo this kind of trials, this kind of loading patterns or different functions. We sometimes convert a lab into a classroom into a lab. What happens? It's not that simple. You convert a healthcare facility into something else. What happens? You convert a whole school building. I have seen that personally. A school building is converted into a hotel. It's not that easy. We must know what are all the things that it will happen because it was originally intended for particular usage, and then it ended up with something else. So what can be done, and what happens to his integrity, the structural integrity, and that is how one looks at it. Reliability and analysis gives you a long forecasting. It can tell you what really is its performance, how it will perform if you change its function. It also tells you what will you do if you add certain things to the original structure, and if you try to make modifications in the configurations, etc. I don't want to get into this. These are just, I never read my own slides, but these also tells you the tools that we use. Actually, if you see that these tools are known invention, it is not a rocket science. These are things which have been adapted from different sciences and engineering discoveries or whatever available instrumentation, and we made use of it in a different way, in a more diligent way, to get a proper interpretation. As I said, to remove as much as possible the subjectivity part of the assessment. So you get more quantifiable assessment of integrity of the structure. Now, load testing, that's what I said, that you actually perform a real life load test. This is one of the examples. I just put a slide. This could be in the tunnel, this could be many places. I mean, all the infrastructure which you can think of, where we can actually perform a load test. We have in fact done a mock train, mock passenger train, mock goods train with realistic loading, run over a bridge. I'll tell you the situation. Actually, exactly at this point is the where this happened. There was a decision some time back. Some of you may know that the Ministry of Railways took a call that the cargo load can be suddenly increased. Earlier they had defined the cargo load should be this one. They said for want of revenue or whatever reasons, that was put, the Ministry of Railways said now we can allow cargo load by so many times, order 1.2 factor, 1.7 for broad gauges. We can allow that much extra cargo, and thereby they also increase the axle loads of the engines. So today what you see is a very different engine than what you had 15 years back and 20 years back. The engineers that time did not understand the decision that was made by the ministry, implications of the decision. We have in the country today more than 1,27,000 railway bridges in the country, which are more than 100 years old. Now imagine, these bridges were designed for what load and what life. See, I gave you the chart. Look at the life. The more than 100 years. Sometimes I have selective deafness. So I will take another couple of minutes and I'm done. So imagine the implications of all this. 1,27,000, that is a major business. We did entire South India, all the bridges, re-examination, and we found that there are certain places you need to do not just retrofitting, but you have to increase the life of the structure. So this is very interesting because you are looking at whether you want another bridge. It's like a surgeon cannot say that a person has to die, it's with cancer or terminal disease. We have to see that, we can never say demolish a structure. Our solution should be how you can improve its life and its integrity. And we're talking about assessment. So, talking about structural integrity, how you can improve by doing certain cost-effective measures, and that is what exactly we had proposed. That has gone to RDSO and it became a part of a guide. This is what I was trying to say at the end is, most of the things we have in civil engineering and infrastructure engineering, but what we have lacking is a guideline and a standard. Now we go by case to case and improve upon that and make a guideline. So that is what is the way we are looking at standardization. So these are the, see, I have listed here 4 challenges, but besides these 4 challenges, is only when you address these 4 challenges, it can lead to some rational guidelines and standards. And these are the requirements, and that depends on infrastructure to infrastructure. Even ports, you look at harbors, there are issues. How to look at the structural integrity. It's not so simple because our country has 2/3 of its border with the sea and highest rate of corrosion after, on the east coast, we have highest rate of corrosion because there are certain issues. We have a sulfur content more, we have carbon, we have, and in terms of humidity, we have more higher humidity in the air. So these causes a lot of distress in the structure all over the coast. So these are some of the challenges in terms of assessing its structural integrity, whether it is made of, we saw some examples of concrete. Most of the persons, I mean, we see that, references are in concrete, but we should also look at other structures like steel structures, and there are composites as well. So which actually tells you. So I actually wanted to say that, all these things must look at sustainability as its main core parameter to design a standard and design a structure and make sure that the structural integrity and its performance is as per the expectations and as per the design. Thank you very much for your time. I am exceeding by 90 seconds. So
It was so good.